Hi, I'm Erlend Oftedal. I work at a Norwegian company called Blank, here in Oslo, not too far from here. I used to work at a company called Beck for 10 years, and then I worked for F-Secure for 1 year, and I've been doing more and more security work during my development career, let's say. And one of the things that I've taken an interest in the last years is something called threat modeling. And it's great to see so many of you here because I think this is an important topic that will be useful for a lot of, it's getting increasingly important for developers, I think. So just quickly, I do all kinds of stuff. I'm still a developer, but I also do security testing, penetration testing, stuff like that. I'm also a bug bounty hunter now, so security is everything I do basically, except for kids and family. I build open source tools. I'm also head of the OWASP Norway chapter. So if we're going to secure a system, that can be quite hard. How do we know what secure actually means? Secure can be many things. And if we don't think about it, we will end up kind of optimizing in the wrong places. If we go to a conference, a typical developer conference, people will talk about things like, making stuff bulletproof with technology. Or if you're not using technology, your software is never going to be safe. And the thing is that most of these technologies, they are just optimizing a part of the pipeline. And if we're not thinking about it as a whole, that's not going to work. So there is no free lunch. We're not going to magically make our systems secure. And threat modeling is not going to magically make your system secure either, but it's a part of a bigger puzzle. So to build secure systems, we need to do threat modeling as one exercise, but we also need to apply a set of other practices. We need to have a secure development lifecycle, which consists of a lot of activities. But today I'm going to focus on threat modeling. A thing to note, though, is threat modeling takes time. It's not something that you can do in an hour and then just leave it. And this is true for security as a whole as well. It's not something that you can kind of do, this week we're going to do security, or we're going to do security just before the release because we'll fix everything then and our systems are going to be perfect. This is something that needs to be continuous. So you could kind of look at security like UX or other things that need continuous effort. When we talk about security, flaws and bugs quickly come up. Like, what is a security bug and what is a security flaw? And bugs are things that we typically make wrong when we write the code. So let's say we write a piece of code and we accidentally introduce a buffer overflow or a SQL injection vulnerability in the code. That's a bug. A flaw, on the other hand, is more like a design thing. So maybe our system has a problem if you kind of look at the wider picture. So from the code perspective, it looks safe. But if you try to call things in the wrong order or things like that, then your system becomes vulnerable. And the company Cigital, they say that around 50% of all security issues are flaws and 50% are bugs. And we've tended to focus a lot on the bugs through the last years. Like we talk about things like SQL injection and cross-site scripting and buffer overflows and things that are very much in the bug space. But we need to talk more about flaws, and we need to focus more on flaws. And that's what threat modeling brings. So what are the benefits of threat modeling? Well, it helps us define these design flaws early. And of course, finding stuff early is important because if we can find it early, we can fix it early and it gets cheaper. If we create a whole application and then we decide, oh, we have a design flaw in here, it might be very hard to fix it, very expensive to fix it. But if you can find it early, that's a lot better. It can also help us to guide how we implement the software, how we design the software, because we can start to draw things out and then we can figure out, oh, if we do it like this, it's going to be really hard to secure this stuff. On the other hand, if we do it in another way, it's going to work perfectly. Threat modeling also has a huge benefit in increasing security awareness in the team, especially if you bring everyone in the team in to do the exercise. It can also improve privacy because privacy and security goes hand in hand in many ways. Of course, there are some issues there as well. Sometimes security people want to have a lot of information, and from a privacy perspective, you don't want that information. But thinking about what you're storing and where has a privacy benefit. This is a quote from a participant in a threat modeling session that I was facilitating for a company. Now I finally understand how the system works. And it was not because the guy was stupid or anything. It was just he had now, often in a team, there will be some people working on something and someone else will be working on something else. And the guys over here, they won't know exactly how the stuff over here works. But after the threat modeling session, everyone in the team had the same picture of the software. Now I've been talking a lot about threat modeling, but I haven't said what it is. So what is threat modeling? Well, this is a picture from Oslo. And we're kind of doing threat modeling every day. If we're going into a city and we want to cross the street, we check, is there any chance of me getting hit by a car or a tram? If we're going to a different city, maybe we check some guidebooks. Is it okay to bring an expensive camera on the street, or will I get mugged? How much money should I bring? Like if you go to, I've heard that if you go to Rio, you shouldn't bring your credit card, but you should bring enough cash for the mugger to be happy if he mugs you. So it's you have to think differently in different places of the world. We also think about this when we buy a bike lock. Like, what are the chances of my bike getting stolen if I have this really cheap lock or if I buy a more expensive lock? So we kind of do threat modeling all the time, but for different things, not for software. But then what's a threat? I'm going to highlight two things here. A threat could be, this is from Wikipedia, I think. A threat could be a person or thing likely to cause damage or danger. But it could also be the possibility of trouble, danger, or ruin. And when we talk about threat modeling, we often talk about both of these, because there are many ways of doing threat modeling. We could do asset-based threat modeling, in which case we focus on the assets that we have. Okay, we have these pieces of data, we have these pieces of hardware, we have these things here, and we can try to focus on how can we protect those assets. If we go with attacker-centric threat modeling, we're kind of trying to figure out who would attack us and what are their capabilities. Well, the one that I've been doing most is the last one, called software-centric threat modeling. And that's where we're trying to focus on the software that we're building and how it can be abused. And I think this is the one that's most fitted for developers to participate in. So when should we do threat modeling? I really like this Chinese proverb. The best time to plant a tree was 20 years ago. The second best time is now. Point being that if you haven't done threat modeling already, now is the best time to start. But you should do it as early as possible. And I've already mentioned why. Well, because if we can catch flaws early, we can fix them early while there's still time. And it doesn't become that hard or expensive to fix them. We should also do threat modeling whenever we do a large architectural change to our software. So let's say we're moving things around, maybe we're splitting out into a couple of new microservices, integrating with some new system. All those kinds of things are triggers for a new round of threat modeling. We could even do like small versions of threat modeling for features. Like we implement a new feature, we do a quick threat modeling, just how will this affect our security? But how? How do we do threat modeling? Well, if we're going to follow like the full scope of a threat model, this is kind of the stages that we will go through. We might not want to do all of them every time, but this is a good start. So, scoping. This is super important. If your scope is too wide, you're going to spend too much time and you're going to get lost in the details. If you narrow the scope too much, well, the accuracy is lowered because there might be stuff that you won't catch because your focus is too narrow. Maybe the threat is when these two components are interacting and you're only focusing on one of them. But it's important to kind of start out broad and then get more detailed as time goes by. The next thing we want to do is to model the system. And there are many ways of modeling the system. Adam Shostak, who is he wrote like the Bible of threat modeling, and he works at Microsoft. He came up with this: all models are wrong, some models are useful. Point being that if I'm gonna propose a way to do threat modeling, but if that doesn't work for you, stop drawing your systems in that way and do it some other way that works for you. I also like this quote from Einar Høst at NRK, and he said, if you're going to navigate through a swamp, you don't want a generic map of a swamp. And the point being here that often our documentations of our system, they are very generic. So, like, how many of you have seen, like, okay, so we have a typical 3-layer architecture. So our only architecture drawing is like a presentation layer, business layer, data layer. That's all we have. And it doesn't really model our system, because that can model any system. It's the generic map of a swamp. So we want something that models our system, that's detailed enough, but we don't want to spend too much time on it either. It can't be super detailed in such a way that we will stop keeping it up to date. So granularity plays a role here. We need to start with an overview, detail as we go through storytelling. One of the biggest mistakes that people make when they start doing threat modeling is to get too detailed too early. So we can also split our diagram into sub-diagrams. If something becomes too complex or too repetitive, we can split it into a sub-diagram and just reference it. And these are some of the trigger words that you can use to figure out if you need to detail your system more. If you're trying to tell a story using the current model, and you kind of pick up on these words like, oh, sometimes there's a different path through. Okay, then there's something missing in this diagram. I attended a threat modeling training. I've been doing threat modeling for quite a few years, but I attended a training about a year ago where they kind of taught me a different way of drawing systems that I've ever done before. And at first it looked really, really strange, but after doing it for quite a few threat modeling sessions, it actually makes a lot of sense, and I found that it gives the best results for now. And it's the same approach that Adam Shostak has in his book. It's called data flow diagrams, and we have these elements in a data flow diagram. So an external entity is something that we talk to, communicate with, but not something that is in scope for the current thing. We're not going to change that thing as a part of this threat modeling session, but we have to communicate with it, talk with it, and think about threats related to it. A data store can be a database, it can be a file system, it can be a cache, it can be any place that we store stuff. And sometimes we want to split a physical data store into several data stores in the drawing to make things simpler. So maybe everything is stored in one database, but we draw it out as different data stores. A process is something that processes, handles, moves data around, because data can't move on its own. And a data flow is the direction that data flows. And often that will be the least intuitive thing about these drawings, because the arrows will appear to go in the wrong direction. Trust boundaries are where change of trust levels occur. So I'll show you an example. So let's say we're building an RSS web reader, just for a simple example. So we have a user, and we have our web app, and we have some data flows between. So the user can submit a couple of RSS feeds that he wants to see, and then he gets data back. And probably the user can log in and things like that. And at this point, the arrows are in both directions, so there's nothing weird about it. We have some user data. This could be stored in a database. It could be stored on the file system. It doesn't really matter. And we're storing data there, and we're also reading it back. So we have arrows going in both directions. We have some static content, because this is a web app. We have some JavaScript files and images and stuff. And now we only have an arrow in that direction, because we're only reading from that data store. And we're also reading from RSS feeds all over the web. So the arrow goes in that direction. If you were drawing a communications diagram, you would typically put this arrow in the other direction, because the web app is contacting the server that has the RSS feed. But in this case, we're reading the data, so the arrow goes in that direction. And this is the part that tends to confuse people. This is one of the trust boundaries that we have here. I mean, clearly here we're crossing the internet. So there's a change in trust level between the user and the web app. We can completely control the web app, but we cannot control what the user is doing. Of course, if we have a separate server with a separate database, maybe it's hosted somewhere else or maybe in a different firewall zone, we might have a boundary there as well. But there's more threats on B1 than B2. Of course, there's also a threat boundary here because, once again, we're traversing the internet to grab this RSS feed and pull it into our system to display it to the user. So there will be different places in our drawings where we will put these trust boundaries. Now, we can start telling stories about this thing. Maybe the users, they want to be, we should be possible for them to have a profile picture. So maybe we split things out a bit. So we have we now have split things out from a web server, and we have a REST API. And we send the picture in. It goes to the web server, it goes to the REST API, and then it's stored in the static content. So now you can see arrows going to static content from two places. And immediately, if you're interested in security and you think about these things, you can think about such things as, well, how do we know that the web server and the REST API are treating this image in the same way? How do we know that they both see this as a JPEG, for instance? Because you can have polyglot files that are valid in many different formats, and so you could be able to trick the web server into displaying something that the REST API thought was an image. But those are the kind of threats that we could find. But we've forgotten about stuff in this, because usually we also have analytics, like Google Analytics or some other statistics tool. So now you say I changed the browser, from the user to a browser instead, because we can control some of the code over there. We can't change the browser code, or some of you can, but normally we don't assume that we're going to change the browser, but we're changing the code that runs in the browser. In this case, it's our code that causes the browser to contact the analytics server. So there might be some new stuff in here. One important thing here is that I've numbered everything, and the numbers are not intended to be a sequence. The numbers are meant because we are supposed to be able to talk about this stuff and reference these data flows. So if I was going to all the time say, well, you know, the arrow that goes from the REST API to the static content, it would be cumbersome to talk about it. But I can just say, you know, DF9, in DF9 we have such and such threat. Maybe it doesn't make that much sense in spoken language, but at least when we kind of type this out later, we can just reference the arrows by numbers. So those are just identifiers. They're not meant to indicate sequence. Sometimes, though, it is useful to indicate sequence. But then we might also want to draw it as a sequence diagram. But it might sometimes be useful. So as Adam Shostak said, all models are wrong, some models are useful. Sometimes we want to use something else. Once we've kind of drawn out this diagram, we want to validate it. Like, have all the data flows been annotated? Do we have all these numbers now? Does data magically appear? Well, at least in the first drawing, data kind of magically appears. How did the static content end up here? Or how did data come in here? Well, we know that because we have two arrows, but here we don't. So there's something, kind of a process thing missing here, but from the application's perspective, maybe that's OK. Does data magically move? We're not supposed to have arrows from one data store to another, or one data store and to some magical entity somewhere. So data needs to be moved by a process. And also, are we storing data without it being used? I had an interesting session, I think it was actually this week, where we figured out that they were storing data that they weren't using. So why are you storing it? Well, we used to use it. Yeah, but you're not using it anymore. Maybe you should remove it. Yes, we should remove it. So you can find all kinds of stuff in there. And I thought the opening keynote today was interesting, with talking about simplicity and talking about removing stuff, because that's one of the things we'll see when we start drawing out these systems in this way, that, well, why are we putting things there? This looks really complex, and things are moving in all kinds of weird places where it shouldn't. So it can be an interesting exercise just from a pure architecture perspective. Now, once we've kind of drawn out this stuff, we need to start identifying the threats, because that's the important part here. the goal of this exercise is to find the problems that we might have in our system. So the first thing we can do then is to try to rate the threat boundaries. And the reason why we rate the threat boundaries is because the most important threats are usually amongst the most important boundaries. So this is just an example rating. So if one of these boundaries is the internet, then there's a big attack surface there. But if it's between two systems in a trusted network, then maybe it's less of an interesting boundary. Also, things like if it's web, then the web opens up a huge attack surface. If it's mobile, maybe we forgot stuff, so we might want to increase the rating of the boundary just because of that. I also think that it's important when you're doing a threat modeling session to focus on issues that cannot easily be found otherwise. So don't focus too much on traditional bugs, focus more on flaws. So don't think too much about, well, what if there's a buffer overflow in this thing? It might be interesting because you might say, well, if this thing is breached, what happens to the rest of the things around it? But I would first start with things that are typical design problems and then maybe move to the more nitty-gritty details later. Microsoft at some point suggested this as a way for finding threats, and this is a useful tool for finding threats. It's not meant for categorization. So if you find a threat, it's not important to try to figure out, is this a spoofing threat or information disclosure threat? The point of this is it's a way to find the threats. So I'm going to go through them quickly. So spoofing is pretending you or something you have is something else than it is. So you can kind of call it anti-authentication. So you could spoof an IP. You could spoof a user account, you could spoof a file, you could spoof a process. Spoofing certificates have been very popular with mobile apps because some of them allow self-signed certificates. All these kinds of things. Spoofing display name, that can also be interesting. What happens if in your system, I can have a display name administrator, and then I start sending messages to your users, and it all appears to come from the user account administrator? Well, I might be able to phish some stuff just because I put a display name there that made me look like I had more authority than I had. So the control that we want here is authentication. We want to ensure that nothing can be spoofed, or as little as possible can be spoofed. And we probably also want to have some kind of input validation of things like display names and things like that. The next point is tampering. So tampering is about changing things that you're not supposed to be able to change. This could be modifying data across the wire. It could be tampering with a database. It could be tampering with a file or a link to a file. It could be modifying memory, one process modifying the memory that another process is reading. It could be all these kinds of things where we're messing around with data that we're not supposed to be able to mess around with. So in this case, we want some kind of integrity protection. This could be signing things. It could be using certificates. It could be all kinds of stuff where we're protecting the integrity of the data. Repudiation is around not being able to deny that you did something. So if in a typical banking application, this might mean someone trying to say, well, it wasn't I who did this. It wasn't I who I have never received this message from you, so you cannot give me any penalty because I've never received this thing. I've been a victim of fraud. Someone stole my account. So maybe having good logs, audit logs, etc., those are good things to kind of be able to see these things or be able to prove these things. An attacker might be interested in trying to fake log messages and kind of destroy our log or make sure our log looks like it has been something has been done that hasn't been done as well, which is kind of on the border of tampering. The next one is information disclosure. So we could leak stuff. We could leak all kinds of things because we could have unencrypted channels, unencrypted communication channels. We could have publicly exposable logs. We could have publicly exposed databases. We could leak information about the internal workings of our system, such as versions and frameworks. Everything where we accidentally or just because we didn't think about it, we are leaking information. A typical example here is also things like accidentally pushing passwords and keys to GitHub, those will be picked up immediately by someone with less nice reasons for doing it. So in this case, we want confidentiality. So we might want to encrypt stuff. We might want to configure our systems so that they don't expose things that we don't want to. We might also want to remove data that we're not needing anymore. And here GDPR and privacy comes in. Like if we're removing data, it can't be stolen because it's not there anymore. The last one is denial of service. Denial of service is stopping the environment from responding. And in this case, it could mean overloading all kinds of stuff in our application stack. It doesn't have to be a distributed denial of service attack where you have multiple actors around the world all posting stuff to your system. It could be the one REST call or the one call that you have in your system that's really expensive, and then firing a lot of requests towards that one call from one machine can be enough to take down the system. It could be filling up the disk. Let's say you have an image upload feature that we just implemented, and you have a limited space disk, and then you have no limit on the size of the images that can be uploaded. And then you fill up the disk by uploading large images, and then the system just goes down. So in this case, we need some kind of availability control. So we might want clustering, we might want network equipment to stop distributed denial of service attacks. We might want to move out the data storage from the host storage of the OS so those do not affect each other, etc., etc. And now the last one is elevation of privilege. Elevation of privilege means calling functions on a higher authorization level than you're supposed to. So it could mean that an anonymous user is allowed to call functions that are only supposed to be available if you're logged in, or maybe you're logged in, but you can call admin functionality that you're not supposed to be able to call. It could also be remote code execution, because then maybe you're sitting anonymously out on the internet and you can send a piece of code in and have it run on the server. So it's running on a different authorization level than it's supposed to. So in this case, we want to have proper authorization controls. Now that we kind of have this toolkit in place, we can think about where we want to apply these things. On these external entities, we want to think about whether or not they can be spoofed, or whether or not they can deny that they did something. On the process itself, we think about the full stride. On a data store, we think about things like, can someone tamper with this data store? Does it leak information? And can someone stop it from working? And if it's a log, we also think about repudiation. Can someone fake log messages or do anything else to this log? On data flows themselves, we think about, can someone tamper with the data as it's flowing here? Do we leak information while the data is flowing here? Or can someone stop this data from flowing altogether? Please don't try to reinvent everything, try to figure out everything. There are a lot of good resources online if you haven't done this before. OWASP ASVS is a set of controls. It's a huge set of controls, actually, but it's a really good read, and I highly recommend you read through it at least once. You have KPEC. You also have tools that can help you. Microsoft has created a threat modeling tool that kind of follows this process, but I don't necessarily want to use it. But also Iris Risk have created a threat modeling tool where you can kind of model your system, and it will automatically give you some threats that you might want to think about. And OWASP is also coming up with something new called the OWASP Threat Dragon. This is the Microsoft threat modeling tool. So you can see the drawing they're using the same elements in this model up here as I just showed you. Like you have the external things that are a square or a rectangle. You have the processes that are circles, and then you have a data store all the way over to the left. In this case, they've also annotated with different controls. So you can see they've annotated with HTTPS here. And they're kind of labeling some of these data flows. And this tool will actually also try to generate a lot of threats for you and make you think about the full stride for the different elements. Another tool that came out of Microsoft, which is kind of interesting, is this. This is a card game. And a card in this game, you can play it if you can find a threat that's relevant to your system. So you divide out all the cards, and then you can, I've uncovered the threat such and such, and I'm going to play this card, and then you get points. Of course, the the full goal of this tool is to help you find threats, not to win the game, but you can kind of gamify it a bit. And OWASP has come out with a similar thing called the cornucopia, which is more angled towards web applications, while the Microsoft version is more for every kind of application. So they're very much the same, they just have a little bit of a different focus. When we've found all these threats, we want to document them. So we want to have, this is a simple way of doing it, like we have an ID for the threat, we have which elements of the diagram is involved in this threat, and then we have a description. Of course, the descriptions here are very generic. They could be longer, they could be more in-depth, but you get the point. The point is you have an ID, you have a set of elements that the threat is around, and then you have a description of the threat. So if we have an application looking something like this, what are the threats that could be in here? So we have a simple mobile app that might be running on iOS or Android. We have a mobile API, and we have some user data. Well, sometimes, or I get the impression sometimes that developers these days, they don't think about threats at all. So if I do something like this, some of you might recognize what this is all about. So this was a Norwegian company, Rema 1000. They had a new app that came out, and they haven't really thought about what you could do in this app, because they kind of moved security all the way to the left, outside a zone can't be trusted. So if you just modified the URLs that this app was communicating with the server, you could steal other people's data. You could even steal their masked credit cards, because they thought that because you were logged into the app, or at least I'm not sure they thought that, but that's the way the application worked. If you were logged into the app, you had full access to the entire API. There was no access control. But if they had drawn it like this instead, it gets immediately clear that there is a trust boundary here. And if we start to think about spoofing here, it becomes clear that, well, what happens if we try to spoof a user towards this API? Interesting. We immediately see it. This is kind of the way that the app was working. I'm not sure that was, of course, not what they intended, but that was kind of the way that they were thinking based on just the code. Like all the security decisions are made out there. It doesn't really matter. Well, they should have thought of it like this. The next example is an insurance app that was recently had a security vulnerability. So in this case, you could ask for information about a car based on the license plate. The problem was that they revealed a lot of information in the calls, where you would ask for information about the car. You would get back all kinds of information about who owned this car. Things like you could ask for the Norway's King's car, and you get information about that. So there are a lot of things here that shouldn't be exposed. So this is a classic example, once again, of information leakage that was in this thing. Also, the guy who found this stuff, he found that you could run these requests and you could find hard-coded usernames and passwords for this service. And this was a service that wasn't intended to be used externally. So you can imagine this as the simple model of this. So we have the mobile app all the way to the left. We have their system here with some user data, and then they were asking for information about cars from this web service down here. But this web service, the use case for this web service was intended to be used backend to backend. It wasn't intended to be used directly out there. So, but if we started to think about information leakage across these, we might have investigated what's actually happening here, and we might have seen that this data that we weren't supposed to have was actually flowing in the wrong direction, out there, out across a boundary into a place where we have no control. So I don't mean to make fun of these apps. I just find them to be interesting examples of where threat modeling could help solve some issues. So back to our RSS thing. So maybe we want to, instead of uploading this image to our user data or to our own file system, maybe we want to upload it to a CDN because CDNs are everywhere and it's faster, et cetera, et cetera. So maybe we create an upload service. And in this case, you can see I've actually used sequences. So now we upload the image goes to the CDN, we get the URL back, we pass that to the user, and then we pass it to the REST API. So just by looking at this, at least I can immediately see an issue here. What happens if the user between 3 and 4 decides to change the URL? Will we then know that this URL, will the REST API, will it just happily store this URL in the database? Or will it do some kind of a check? I don't know, maybe it will, maybe it won't. But this is something to think about. Why are we doing it this way? So this is a design flaw. It could be a design flaw. At least it's something we need mitigation for. Once we've found a set of threats, we need to rate them. And rating threats can be kind of hard. The easiest way to go is probably to just do relative rating. So is this threat more important than this threat? But we can use other sources as well. So we could come up with a set of doomsday scenarios. What's the worst thing that could happen to our company? And if any of the threats are dragging us towards one of those doomsday scenarios, then maybe we want to put that on the top. If we've done risk analysis, we can use the results of risk analysis and see, any of these threats help us or help an attacker into getting our systems exposed to one of these risks? Well, okay, maybe we can rate them accordingly. Microsoft used to use something called Dread. They're not using it anymore, but it has some interesting properties because it was about how easy is it to discover this threat or this bug or this flaw. How easy is it to reproduce this vulnerability? How easy is it to exploit it? How many users does it affect, et cetera, et cetera. So you kind of try to put some numbers on things to get a number at the end. You could also use something like CVSS, which is a common way of scoring vulnerabilities in systems. So once we've rated them, of course, if that's all we do and we don't fix them, well, we haven't gotten much further. So we need to plan some kind of mitigation of these bugs. So we need to ensure that we've at least tried to cover all the threats with mitigations. We might find that sometimes we can't mitigate the threat. And sometimes we don't want to mitigate the threat. Maybe if we're implementing a web shop and we find that, well, one of the biggest threats we have in our web shop is credit card data. Okay, maybe we can, instead of processing credit cards ourselves, we can transfer that risk to someone else. And we could say, well, we'll use Nets or someone else, and they'll handle the payment, and we'll just be the web shop, not the payment processor. So you can transfer risk to someone else. Normally, what you want to do is apply standard mitigation. So for instance, if there's a data connection that's unencrypted, you encrypt it, you add TLS. But sometimes you can't, and then you have to create your own mitigations. But that's something you really should try to avoid doing because it's really hard to get it right. Sometimes your only options is to just accept that there is a vulnerability in the design because it's going to be too costly to fix it, and maybe the risk or the impact of this threat isn't as bad as it could be. Maybe if it's like a small information leakage and no one really cares about it, well, maybe it's okay to leave it there. But at least you know about it and maybe think about it again some time later down the road. So we want to figure out which mitigations we have and document those as well. And you can see here I have one mitigation that covers 2 threats. And this is very common. This is why I'm splitting between this is the threat and this is the mitigation. It's because, well, sometimes we can fix many threats with just one single thing. The end result of this is that we need to document this somehow. I find that I used to draw threat models on whiteboards such as this one. But at some point I found that that's a bad idea. And the reason why is once you start drawing out the system, some of these boxes are going to be in the wrong spot. You need a new box in between them. And it's really hard to move boxes on a whiteboard. But if you draw them in, let's say, Glyphy and Confluence, or if you draw them in Visio, or some where you can actually move things around and just put that up on a projector, it actually becomes easier to move things around. So it's a bit more cumbersome to begin with, but it's actually easier to move things around and get the proper structure of it as the session goes on. Once we've kind of documented the model and we've documented all the threats, a thing that I really like to do as well is to have a last column here when it comes to the mitigation and just link in the issue tracker. So I register a case in the issue tracker and I link that in here. So it's really easy to check the status. Is this mitigation in place? Well, I can click this link and I can see it, or if you're using Confluence and Jira, you'll magically get the green thing here. But at least there is a link between the threat model and what you're actually doing. Because if all you have is this document lying in your drawer, or this document in the wiki somewhere and no one cares about it, well, the whole threat modeling session was a waste. But as long as you can link them together, it really becomes a much better process in the end. So, to try to summarize this, threat modeling, it helps us uncover design flaws. This is one of the most important properties of threat modeling. But I also think that drawing it in this way provides a language for us to discuss security and vulnerabilities, because we can now gather all the developers in a room, we can draw out the system, and one of the things I often find interesting is how much developers will disagree about what system contacts which system. At one company, this is a long time ago, I was doing a threat modeling where they had a firewall zone, and there was supposed to be only connections out of this firewall zone, not into it. And while we were doing the threat modeling session, one of the guys said, well, this thing is contacting this thing that sits inside this firewall zone. And the other guys were like, no, it's not possible to contact something inside there from the outside. And it turned out the guy was right. There was a connection from the outside into a firewall zone where there were supposed to be no connections. So just by drawing it out in this way, we found a design flaw that you can't find by inspecting code. Also, it increases the understanding of the system, because as I mentioned, you might have developers over here that are working on a tiny feature, and developers over here are working on another feature, and you don't necessarily know what the other guys are doing. You know that they're working on this feature, this thing, but you don't know how it works. But after one of these sessions, hopefully everyone understands more of the system. To kind of end this, I really recommend this book. You should read at least the 3 first chapters of this book. But the more the better. It's a really good book. This focuses on the type of threat modeling that I've just been talking about. And then last but not least, remember, thanks a lot.